Alright, so video 3, 6.4, and just a couple more things I wanted to talk with you about. So let's continue to talk about domain of a logarithmic function. And we've already talked about the fact that will go from 0 to infinity. So we have a restricted domain, just like we've talked in the past with radical functions and rational functions. There are values of x that don't work. So you have to pay particular attention to these types of functions and be comfortable with identifying their domain. So for example, you will be asked to find the domain algebraically. If I told you y is equal to log base 2 of 1 minus x, I said, what is the domain of this function? Well, because the domain of y equals log base a of x is from 0 to infinity, basically I can't apply log to a negative number. So that means that 1 minus x can't be negative, or I can say 1 minus x must be strictly greater than 0. And then solve the inequality, and I'll be able to identify the values that will make this expression negative. So I would subtract 1 from both sides, so negative x is greater than negative 1, and then I would multiply negative 1 to both sides. And when I do that, remember I have to change the direction of the inequality, so x is less than 1. So that means the domain of this function is x less than 1. So if you're asked to identify that in interval notation, we would say, here's 1, I want numbers smaller than x. So this would be from negative infinity to 1 for the domain. So basically when you're asked to find the domain, you want to take the expression that the log is being applied to and set that strictly greater than 0, so you can identify the values that would make that expression negative. And then you can test that. So if I pick a number smaller than 1, like 0, 1 minus 0 is 1, that's a positive number, that's okay. If I pick a number like negative 2, I would have 1 minus a negative 2, which is 1 plus 2, or 3. So that makes sense, that works, and that's how you algebraically find the domain. Okay, other things that you'll be asked to do in terms of your homeworks assignment in the MyLabs Plus. You may be asked to solve a basic equation. So the directions would just say solve, and you may see something like log base 2 of 9x plus 3 is equal to 2. Okay, so two things. For one, we know how to change this to an exponential expression, and in that way we'll get rid of the log and we'll be able to solve this. So let's do that first. We'll have 2 to the 2, so 2 to the 2, remember base of my log is the base of my exponent, so 2 to the second power is equal to 9x plus 3. So now this is something I know how to solve. 2 squared is 4 is equal to 9x plus 3. So getting x by itself, I would subtract 3. 9x is equal to 1, and x is equal to 1 over 9. Now, because I have a restricted domain, I must check my solution. So if I plug 1 over 9 back in, I'll have 9 times 1 over 9 plus 3 is equal to 2. So I'll have log base 2, so this will just give me a 1 plus 3 is equal to 2. So I have log base 2 of 4 is equal to 2, and now when I change this to an exponential, I get 2 squared is 4, which checks. So my solution is x equals 1 over 9. Okay, one last example. Finally, I'd like to look at a function. F of x is equal to the natural log of x minus 3. And let's go through the process of now finding its inverse and then identifying the domain and range of f and f inverse. So we're going to use the same algebraic procedure that we used back in 6.2, except now we're dealing with exponential and logarithmic functions. So remember, first thing we want to do is rewrite this, just change the f of x to y, and then interchange the x and the y. So x is equal to the natural log of y minus 3. Now I need to solve for y. So what we need to do is change this to an exponential expression. Remember, natural log means my base is e. So I can rewrite this as e to the x is equal to y minus 3. Remember, the object here is to get y by itself because that will then denote my inverse function. So I'm going to add 3 to both sides. So y is equal to e to the x plus 3. So that is f inverse. So now let's identify domain and range. Remember, the domain of f is the same as the range of f inverse, and the range, or I should say the domain of f inverse is the same as the range of f. So we can kill two birds with one stone. So what is the domain of f? Okay, f is a log function, and x minus 3 must be positive. So x must be greater than positive 3. So the domain would be all real numbers greater than 3. If I want to use interval notation, I would say 3 to infinity. Now what about the domain of f inverse? F inverse is an exponential function, so the domain is all real numbers. So by identifying the domain of both functions, I'm also identifying the range of both functions. Okay, and that's a wrap. You should feel comfortable now tackling some of the problems in the MyLabs Plus. The MyLabs Plus for 6.4 was separated into 3 different sections. A lot of computational kind of things, interchanging between logs and exponential functions and things like that. So take some time and we'll take a look at it in class.